Hello students. Question is find limit x tends to 0 greatest integer x e to the power 1 by x minus 1 upon e to the power 1 by x plus 1 where greatest integer represents this square bracket represents greatest integer function. So let's solve this problem. Here first of all I am going to find limit x tends to 0 plus. Okay, so this will become greatest integer 0 plus, okay, e to the power 1 upon 0 plus minus 1 upon e to the power 1 upon 0 plus 1. Now see, 1 upon 0 plus tends to infinity and e to the power infinity tends to infinity, and here numerator is infinity minus 1 which is equals to infinity, and denominator is this part is infinity, so infinity plus 1 is equals to infinity, and this becomes infinity upon infinity. How do we solve infinity upon infinity? See, we see which infinity is greater. This is concept. Whenever you face infinity upon infinity, always try to see which infinity is greater. Like, let me explain you this concept. E to the power x upon x, limit x tends to infinity. What will be its value? We'll see which infinity is greater. This infinity is greater or this infinity is greater. Okay, so e to the power infinity is greater or infinity is greater. Value of both is infinity, but which infinity is greater? This e to the power infinity is greater. How? Draw graph. This is graph of y is equals to x for the denominator function y is equals to x, and this is e to the power x. You can see e to the power x is always above. So at any x, like x is equals to 1, which will be greater? This point will be greater or this point? Of course, this point will be greater. So at infinity, this curve is above. It means that this infinity will be greater than this infinity. So when numerator infinity is greater than denominator infinity, answer is infinity. Okay? When numerator infinity is less than denominator infinity, answer is 0. And when both infinity are same, then answer is coefficient of above infinity upon coefficient of denominator infinity. Now I'm going to explain you here. See, above infinity is this one, e to the power 1 upon 0 plus e to the power infinity, this one. Both infinity is same. So if both infinity is same, then answer is coefficient of numerator infinity upon coefficient of denominator infinity. Okay? Numerator infinity coefficient is this part. This makes infinity numerator, so its coefficient is 1. And denominator infinity is made by this part, so its coefficient is also 1. So 1 upon 1 will give 1. Okay? And this is 0 plus little greater than 0, and their greatest integer will be 0. So 0 into 1 will become 0. No problem. Now let's move to limit x tends to 0 minus. X tends to 0 minus. See, I am writing greatest integer 0 minus. Here I will write e to the power 1 upon 0 minus upon 0 minus minus 1 upon e to the power 1 upon 0 minus plus 1. Okay? See, 0 minus is little less than 0. It means that 0 minus is less than 0 and greater than minus 1. Okay? So greatest integer of this number will be -1. So this will become -1. Okay. Now see, 1 upon 0 minus. 1 upon 0 plus is plus infinity, and 1 upon 0 minus is minus infinity. So this will become e to the power minus infinity minus 1 upon e to the power plus infinity, minus infinity plus 1. Okay. See, this e to the power, both infinity is same. Both infinity is same. What I am going to do, I am going to write e to the power minus infinity as 1 upon e to the power infinity. E to the power minus infinity is equals to 1 upon e to the power infinity. So this will become minus 1 into 1 upon e to the power infinity minus 1 whole upon 1 upon e to the power infinity plus 1. When we'll take LCM of this e to the power infinity, what will be LCM? See, the calculation will be -1, which is over here, and here it is see calculation is this. So I'm going to take LCM of both denominator and combine both. So what we'll get? -1. Okay, and in numerator this is 1 upon e to the power infinity, and this is 1 upon 1. So in denominator e to the power infinity is there and 1 is there, and LCM of both will be e to the power infinity. And in the first term, denominator is e to the power infinity, so there will be 1 minus e to the power infinity upon, when we will do the same in denominator, here LCM will be e to the power infinity, and there will be 1 plus e to the power infinity. And here e to the power infinity, e to the power infinity, both will get cancelled out, and we'll get -1, 1 minus e to the power infinity upon 1 plus e to the power infinity. See, in both numerator and denominator, 1 minus e to the power infinity, e to the power infinity is infinity, 1 minus infinity is minus infinity, and 1 plus e to the power infinity is infinity, so 1 plus infinity is infinity. So infinity upon infinity will become infinity. Okay, so what we'll see? We'll see which infinity is greater, numerator 1 or denominator 1, or both are equal. If you see, above infinity is made by this term and denominator infinity is made by this term. Okay, so both infinity is same, both infinity is same. It means that answer will be coefficient. So this will be -1. Coefficient of this infinity is -1, and coefficient of this infinity is +1. So this will become -1 into -1 plus 1 upon 1. So this is 1. Okay. Earlier we found RHL is equals to 0, and here LHL is equals to 1. And we can say RHL is not equals to LHL. So limit x tends to 0 does not exist. Does not exist. Thank you, students.